They say the universe hides its greatest secrets in plain sight, buried inside the very monsters we fear the most. Imagine, for a moment, a source of energy so powerful that it could outshine entire galaxies, a force that could fuel civilizations for millions of years, reshape economies, and maybe even bend reality itself. But what if that source isn't buried deep under our feet, but far above us, in the dark void of space, inside something we once believed destroys everything it touches, a black hole? Now, that sounds insane, right? I mean, a black hole, the ultimate cosmic vacuum cleaner, devouring everything, even light? But what if? What if we could turn that destruction into creation? What if the same thing that swallows stars could one day power our cities, our spaceships, our entire future? All right, before you laugh it off, let's take a trip through time, through gravity, and maybe through the edge of what's possible. Picture this. It's the year 2100. Earth's population has exploded past 11 billion. The demand for power has tripled. Fossil fuels are ancient history. Solar panels cover entire deserts, and fusion reactors hum in the background like electric suns. Yet, even with all of that, it's still not enough. Data centers, AI systems, interplanetary travel, our hunger for energy keeps growing. And that's when someone, somewhere, asks the forbidden question. Could we tap into the power of a black hole? You see, in the heart of a black hole lies something called the accretion disk, a swirling storm of gas, plasma, and pure chaos spinning near the speed of light. As matter falls in, it heats up to billions of degrees, releasing more energy per ounce than any fusion reactor could ever dream of. Scientists believe this makes black holes the most efficient engines in the universe. Some even say if we could harness just 1% of the energy around a black hole, it could power all of Earth for thousands of years. But how do you harness a cosmic monster? How do you get close enough without being torn apart by gravity that stretches space itself? Well, that's where imagination meets genius. Back in the 1960s, physicist Roger Penrose proposed a wild idea, the Penrose process. He suggested that if you drop an object into the outer edge of a rotating black hole, the ergosphere, it could split in two, one piece falling in and the other escaping with more energy than it came with. Basically, it's like robbing a black hole, using its own rotation to steal some of its power. Now, decades later, scientists have simulated this process using supercomputers, and it might actually work. But the scale is beyond anything humanity's ever built. To attempt it, we'd need machines orbiting near a black hole, powered by lasers, controlled by AI smarter than anything we've ever seen, and shielded from radiation that could melt metal like butter. Sounds impossible? Maybe. But so did flying once. So did nuclear power. So did touching the moon. Let's be honest though, the risks are enormous. Imagine a miscalculation. One wrong trajectory and an entire probe gets ripped apart in milliseconds. The data, the investment, gone. Or worse, the energy you try to extract spirals out of control, bending space-time around it. You don't just create power, you create chaos. But here's the crazy part. We might not even need to go that far into the cosmos. Some scientists believe mini black holes could exist or be created right here on Earth. Not giant ones swallowing stars, but microscopic ones that evaporate almost instantly. As they vanish, they release enormous bursts of energy, Hawking radiation. If we could stabilize and contain that process, we'd have the most compact, powerful energy source in existence. A generator the size of a basketball, powering entire cities. Of course, that idea freaks people out. I mean, creating a black hole on Earth? That sounds like the start of every bad sci-fi movie. But here's the twist. It's not entirely fiction. Theoretical physicists have already done the math. In particle accelerators like CERN's Large Hadron Collider, the energies are nowhere near enough to make dangerous black holes, but they show us that, on paper, it's possible. And if we ever reach that level of technology safely, it could change everything. Now, take a second and imagine what that world looks like. Cities powered by stable, artificial black holes, each glowing like a caged sun. No pollution, no dependence on oil, coal, or even solar. Just pure, endless power. Spaceships using black hole thrusters, traveling to other galaxies. Colonies lit by the energy of the universe itself. Humanity no longer bound by scarcity. But hold on, what happens if something goes wrong? What if one of those artificial singularities escapes containment? It wouldn't explode. It would just start devouring matter, atom by atom, slow at first, then faster, unstoppable. And that's the nightmare scientists fear. The line between infinite energy and total annihilation is razor thin.
You know, it's funny. Every great leap in history has had that same tension. Fire could cook food or burn cities. The atom could light up the world or destroy it. And now we stand at the edge of the universe, staring at the next big question mark. Do we have the wisdom to control what we discover? But here's where it gets even deeper. Black holes aren't just cosmic drains. They might also be cosmic mirrors. What if they don't destroy information, but store it? What if inside them, hidden beyond that event horizon, lies the blueprint of creation itself, an archive of everything the universe has ever been? If that's true, then by studying them, we're not just learning how to make energy, we're learning the code of reality. That's where artificial intelligence enters the story. Future AI systems might not just help us study black holes, they might be able to think like them, simulating the gravity fields, predicting quantum effects, designing energy extraction systems too complex for any human to imagine. And maybe one day, when humanity builds Dyson spheres around stars, we'll take it further, a Dyson ring around a black hole, absorbing the radiation, converting it into usable power. Theoretically, that could give us an energy output billions of times greater than our sun, enough to power a Type 3 civilization, a society that controls energy on a galactic scale. But getting there, that's the journey of centuries, maybe millennia. Or maybe, just maybe, one genius in some distant future will look up at the night sky and think, why not? So, let's circle back to now, to us. Every time we charge our phones, drive our cars, or light up our cities, we're burning pieces of our planet's history. But above us, right now, the universe is running on a different set of rules, recycling matter into energy with impossible precision. And those black holes we fear, they might just hold the secret to infinite power, waiting for someone brave enough to reach for it. But maybe bravery isn't the only thing we'll need. Maybe we'll need humility too, to remember that power without understanding is just another path to destruction. Still, I can't help but wonder. Somewhere out there in the cold silence of space, a black hole is spinning. Its accretion disk glows brighter than 1,000 suns. Its jets shoot light across galaxies, and hidden in that chaos is a promise. A promise that one day, humanity might finally learn to turn darkness into light. So, the next time you look up at the stars and you see that endless black void between them, don't just see emptiness, see possibility. Because the future might not come from the light we already know, but from the darkness we've yet to understand.